Let me explain the homework problem 2. The homework problem 2 is to find the formula for the uh, sum of integer squares. Okay, like this. So this is the sum of squares, so up to n. Then the formula is this one. Okay, and this is the homework problem 2 to prove the following formula. To prove this one, first let's prove the triangular number formula. The triangular uh, number formula is Tn is by definition. Okay, so we introduce in this way. Sum of integers from 1 to n is called the triangular numbers and denoted by this notation. This is the notation, or as a function formula of this one. This one is equal to this one. And let's consider T4 and T3. And the T4 is 1 plus 2 plus 3 plus 4. So T4 can be represented by this kind of triangular forms. T3 is like this one. Then combining this one, you can combine in this way. So this is T3, this T4. But if you count the number of balls, then this one is 4 squares. Okay. So in general, Tn plus Tn minus 1 is, so this triangle is Tn, and the upper one, this one is a smaller one, Tn minus 1, and this is to generalize this kind of pattern, then this one is n squared. Then from this one, you can prove these triangular formulas in many ways. So, one of the method is, so by definition, Tn plus 1 is the sum of integers from 1 to n plus n plus 1. Okay, this type. But what is this? This one is Tn. Okay, so n plus 1. So Tn plus 1 is Tn plus n plus 1. Okay, then from this, so we have this kind of uh, equation, and then just the above pictures, we prove this one. Okay, we can, this is the general formula, Tn, so Tn plus 1 plus Tn, so this triangle is a bigger one, n plus 1, and this is smaller one, like this. Then in this case, this is n plus 1 squared. Okay, but you can replace this one by what? This one. Okay, Tn plus 1 is just Tn n plus 1, like this. So uh, some of these two Tn plus n plus 1 is n plus 1 squared. Okay, because the sum of those two is n plus 1 squared. So just move this one to the right hand side, and then you can have n plus 1 squared minus n plus 1, and that is 2Tn. And what is this? This is n squared plus 2n plus 1 minus n minus 1 is minus n minus 1. So you can cancel out this one. from 2n minus n, that is n, just n. Okay, so you have this one. Then divide both sides by 2, this one, divide by 2, then you can have this triangular formula. Okay, triangular formula. But there is another way. So you may use this proof also. You may use this proof to prove the triangular formula, triangular number formula. Okay, so our goal is to prove this one, but this formula can be uh, solved using triangular formulas and tetrahedral triangular formulas. So first of all, this is a triangular formula, triangular number formula, sum of integer from 1 to n. But there is another method, and that is uh, the the famous mathematician Gauss invented this kind of method. Okay? So suppose we want to find out Tn 1 plus 2 plus up to n. Now let's consider 2 times Tn. 2 times of Tn, that is 2 times this one. So you can uh, denote this summation using this sigma notation like this. Okay. But anyway, then what is this? Then you can arrange, this is the first sum of integer from 1 to n. But reverse the order, you can have n minus 1 to n. Okay. So the first one is the Tn. The second one is also Tn. What so add summation, okay? Summation. So those two, sum of those two is 1 plus n, and sum of those two is 2 plus n minus 1. Sum of those two is n minus 1 plus 2. Sum of those is n plus 1. Then, well, what is this? This is n plus 1, okay? And also this is n plus 1, n plus 1, n plus 1. So, in fact, there are n many n plus 1, okay? Because how many, the number of n plus 1, number of n plus 1 is n. There are n many n plus 1. So what's the result? So 2 times Tn is n plus 1, okay? Because there are n many n plus 1. So divide both sides by 2. So this is 2 is canceled out, and you can, so Tn is n plus 1 over 2. So you can prove these triangular number formulas using this kind of method, or using this kind of method. Okay, so this is more intuitive. So this is more intuitive proof. Okay, so now secondly, let's prove the formulas. Then let's go tetrahedral. This is a tetrahedral number formula. Tetrahedral number formula is, by definition, sum of triangular numbers up to Tn. Okay, Tn. And then the formula is this one. Okay. This one. So secondly, let's prove this formula. Then in this case, we can use a kind of a recursive formula or induction in many ways. So let's see. So we kind of use a kind of inductive proof. So what we want to prove is tetrahedral number, tetrahedral number. So let's prove in general n plus 1, okay? So in this case, this one is just notation. The notation is tetrahedral number n plus 1. So it doesn't matter, but they have the same notation, but this is the function form. This is the just a mathematical notation. So we want to prove n plus 1, n plus 2, n plus 3 divided by 6. Okay. And then in fact, in this case, this is n plus 1. But in general, what is n? If this is n, then this one is replaced by n time n, and this one is n plus 1 and n plus 2 divided by 6. Okay. So this formula is in fact exactly equal. The only difference is in this case the variable is n and this variable n plus 1. Okay. So let's prove this one instead of this one because they are the same. Then the induction process is, first of all, there are three steps. First of all, let's consider the case when n plus 1 is 1. Okay, so the case when this one is 1. Okay, this is 1. So this one, then this is n plus 1, n plus 2 divided by this is 1. Okay, so when n plus 1 is okay. And next step is the there are three steps. So let's assume that uh, when when this one is okay, this one is okay. So when n is plus 1, n is n, and then next case, let's consider the case n plus 1, n plus 1 case. So this case, okay, this case. So this one. But then in this case, T E n plus 1 is, by definition, T1 plus Tn plus what? Tn plus 1. Okay. So the first, this part is tetrahedral numbers up to n and plus this. So you have this kind of recursive equation. And then since we assume that this one is true, then you can replace this value by this one, okay? This one. And then what is triangular number? But we know that, look at this. This is a triangular number. This is a triangular number. So we know your Tn is 2 times n plus 1. So what is Tn plus 1? Tn plus 1 is, so this is n plus 1, and this is n plus 2 divided by 2, okay? So this one can be replaced by this equation, okay? This equation. And as you see, n times n plus 1, there is the same n plus 1, n plus 2 in the upper part. So n plus 2, and then there is a n plus 2. Okay, no. So n divided by 6. This is the first part, okay? But in this case, this one is, the denominator is 2, so that is 1 over 2. Okay. Then by combining those two, so, so 1 over 2 is just 3 over 6, okay? 3 over 6. So combining this one, n plus 3 is upper part, the lower part is 6. Okay. So by solving this equation, you can have this one. In conclusion, what what happened? So there is an internet problem. In conclusion, we can solve this one. Okay. So in general, tetrahedral number, tetrahedral number n. So in this case, in this one is also can be expressed in this way. So if this is n, then this one is n times n plus 1 times this is n plus 2 divided by 6. Okay. So now this is our second proof. And what's this? Triangular number. This one is n times n plus 1 divided by 2. So combining those two formulas, now in fact, these tetrahedral formulas, let's prove our homework problem. Now let's return to our original homework problem. Homework problem is this one. Okay. But you may see there is a kind of a similarity between this formula and was tetrahedral number formula was this one is n times n plus 1 times n plus 2 divided by 6. Okay. So this one is very similar. The only difference, this is 2n plus 1, but there is n plus 2. Okay. So this is the difference. But so we can see there is a kind of a connection between tetrahedral number formulas and sum of integer, sum of squares formulas. So this is our formulas. So let's prove this one, but intuitively, just consider the case when n is 6. Okay. So using this kind of figures, consider a case when n is 6. Then let's consider n is 6, and this is the yellow one. This one is tetrahedral numbers 6. Okay, look at this. This is 1, and what's the second one is 1 plus 2 triangular number. So this one is 1 plus 2 plus 3. Look at this. This is 1, 2, 3, 4, 5, 6. So there is 1 plus 6. Okay. So this is in fact sum of T1 up to T6. So the yellow part is in fact tetrahedral number 6. Let's consider this sky blue part. Also, this one is 1, and this is 1 plus 2. This is 1 plus 2 plus 3, 1 plus 2 plus 3 plus 4, and 1 plus 2 plus 3 plus 5. So, in fact, this the this A is, look at yellow part A is tetrahedral number 6, and this sky blue one, this one is tetrahedral number 5. Okay, so when n is 6, this one is A is tetrahedral number n, and this is tetrahedral number n minus 1. Okay, so when n is 6, this 5 is n minus 1. So now we wanted to say that that is in fact 1 plus 2, 1 square plus 2 square plus 3 squares up to n squares. We will prove this one. Okay, we will prove this one, and then we already proved the formula for the tetrahedral numbers. Tetrahedral numbers. So you can replace this one by tetrahedral number formulas, and then you can get the formula for this sum of integers. So let's prove this one. This is the key. Okay. So y, a, b, and key. Then let's we must say tetrahedral number 6 is by definition is this one, and then we will show that that is sum of 2 squared, 4 squared, and 6 squared. Okay, the y. Get this because okay. So the you can okay, tetrahedral number 6 from this one, this yellow part, this one, you can get you can decompose this one into this kind of three separated form or figures. Okay, because look at this one, the first one, and this one, the second one, and the last one, like this. And then what is that? This one is uh, 1, 2, 3, 4, 5, 6. The triangle number 6, and this part is what? This part is 1, 2, 3, 4, 5. T5. Okay. So this yellow part is T6 and T5. And let's consider this part. This is 1, 2, 3, 4. That is T4. And this is T4 plus T3. Finally, from this one, this is a T2 and T1. So you can combine, you can separate, this one is you can just uh, separate the part in this way, and from each part you can get T1, T2, T3, T4, T5, T6 like this, okay? Then what is T6 plus T5? Then you may plug in number n plus 1 over 2, but by the geometric, intuitive geometry one, this is T6 and this is T5, a small triangular, and then there is the six square, okay, like this. Remember? So we consider this one here. This kind of um, intuitive figures like that, okay. So then we can say that is is T6 plus T5 is 6 square, and the next one T4 plus T2. Oh, sorry, this is the error, okay? Not this. This must be 3, okay? This must be 3, because this is not T3, not 2. So you must correct this one, okay? And that is 4 square, and T2 plus T1, and last one is 2 squares, okay? So in fact, tetrahedral number 6 is sum of uh, even number squares, okay? Even number squares. And similarly, tetrahedral number 5 is, by definition, this one is, then this is sum of odd number squares, because from this sky blue part, just this one can be decomposed into 3 parts. The outer part is can be did 1, 2, 3, 4, 5, T5, and this one is 1, 2, 3, 4, T4. That is 5 squared. Okay? And the the middle one, 1, 2, 3, T3, and 1, 2, T3, and the 3 squares. Finally, just one is left, and that is 1 squared. Okay, so from this kind of decomposition, uh, A plus B is A is uh, what? 2 squared plus 4 squared and 6 squared, and B is 1 squared, 3 squared, 5 squared. Okay, so that is the number of cubes in this A and A plus B is in fact 1 squared up to 6 squared. So let me summarize. Then when n is 6, we want to find out this formula, and then just think about odd number squares and even number squares like this. Then this is 5, and there is tetrahedral number 5, and this is 6, and then this is tetrahedral number 6. Okay, so when n is 6, then this one can be represented in this way. This one is represented by in this way. Then we just prove the formula like this. This one is from the above part. This n plus 1, n plus 2 divided by 6. Okay, just replace this one like this. So this is n minus 1. So this one is m replaced by n minus 1. This is just n, and this is n minus n plus 1, like this. So this part is this one. By combining, solving this one, you can get this one. Nice. Okay. So from this kind of geometric intuitive decomposition, we can prove the formula for the integer squares. So this is the end of proof. So this one is a kind of uh, intuitive one, and this one is just a figural proof. But that's okay for the discrete mathematics. So this is a tetrahedral number like this. Okay, but there is another proof. So in discrete mathematics, there are many ways to prove the same formulas. But it's up to you to choose a suitable proof for you. The other one, just let's introduce just another proof like this. So our main problem is this one, but this one can be expressed uh, in this way, and then find another this method, and then you can prove the formula similarly. Okay. And also from this one, look at this. The top is one squared, and the next one is two squared. Next one is three squared, like that. Okay. So inside of this formula, there are one, two, three, four, five, six squared. Okay. Then just consider the orange part. Orange part is uh, this is tetrahedral number one, two, three. Tetrahedral number five. Okay. Tetrahedral number, and this the blue part is tetrahedral number six. Okay. Sky blue part. Okay. So mm, this is this kind of this uh, figures is in fact uh, it's exactly equal to uh, sorry, this one. Okay, these figures. Number of cubes is exactly equal to this one. The the shape is different, but the number of cubes are the same. So this is the uh, main formula, our goal in homework 2. And let me emphasize this formula one more time. This formula is very uh, fundamental formula and very important in the discrete mathematics. So there are many other proofs. So like this, but we also in modern discrete mathematics, we can prove this formula using a very famous generating function method. Okay, general function. So the homework 4, uh, home, homework 5. Homework 5 is, look at this. Let's prove sum of integer squares again. Okay, right? Mathematical. This one. Okay, this one. So homework 2 and homework 5, we will prove this formula again in homework 5 using a kind of a generating function. And there is a more algebraic and discrete mathematical method. But in homework 2, we use tetrahedral numbers. So it's a little bit of a geometrical proof, okay? We may use figures, and in homework 5, we may use generating function method. So those two um, method is very important in discrete mathematics, and I want you to understand both proof method for this kind of sum of uh, sum of squares method. Okay, thank you very much for your attention.